Hello, this recording is going to cover the internals of BISM Normalizer, focusing on the object model and the build process. If that's something you're interested in for whatever reason, please continue to watch. I'm not going to cover all the use cases for managing tabular models with BISM Normalizer in this recording. I'll do that in another one soon. The business logic is contained within this tabular compare namespace. It has some child namespaces like UI and core. The core namespace contains abstract classes that are instantiated using classes from the multidimensional metadata namespace or the tabular metadata namespace, depending on the compatibility level of the source and target tabular models. I'm going to use a code map to illustrate a subset of the object model. The main UI component in BISM Normalizer is the comparison control. It hosts the differences grid and the source and target object definition text boxes. It calls the create comparison static method from the comparison factory class that uses the factory design pattern to return an object of type comparison from the core namespace. Comparison is an abstract class that is instantiated using comparison from the multidimensional metadata namespace or comparison from the tabular metadata namespace, again depending on the compatibility level of the source and target tabular models. So it uses polymorphism to abstract the complexities of tabular versus multidimensional metadata. Comparison has a collection of comparison objects, and a comparison object represents a row on the differences grid. If there's a table in the source and target tabular models with the same name but slightly different definitions, that's a row on the differences grid. So the differences grid will bind to the comparison objects collection, and the comparison object abstract class will ensure that the properties necessary for binding will be populated by declaring them as abstract properties here for source and target object definition, for example, that holds the JSON definitions. I built the classes in the multidimensional metadata namespace to abstract the complexities of dealing with the traditional AMO object library for tabular models. Then, of course, the tabular object model, or TOM, in SQL 2016 came out, and TOM obviously already is tabular in nature. So you may ask, why then do I need another shell object model on top of the TOM classes? And the reason is that I need properties and methods for comparison purposes. For example, if we come into the culture class, it inherits from the tabular object class, which deals with JSON serialization in a consistent way for all of these classes and populates the object definition property for us. And there are various methods on these classes for manipulating objects in the target tabular model. So I feel this is a clean object model. There's not much room for improvement. I can't, for example, have my comparison classes inherit from the TOM classes and then add on my properties and methods for comparison purposes. I can't do that because the TOM classes are sealed, as are most of the .NET Framework classes. And even if the TOM classes weren't sealed, that wouldn't work because the TOM classes are obviously instantiated server-side in the TOM object model, which means I can't downcast to my comparison subtypes. The best I can do is expose the TOM objects as properties, as I'm doing here. We're now going to run this code that creates a comparison object from a BSMN file on the root of the C drive, which I already have loaded in another instance of Visual Studio. So we're going to apply this comparison, but we're going to do it from the object model instead of the UI. Step straight in from the immediate window, create the comparison object. So in this case it used the comparison class from the tabular metadata namespace because of the compatibility level of the source and target tabular models. Connect instantiated the classes in the tabular metadata namespace. Compare tabular models populated the comparison objects collection. So there we can see the top level connection and the tables within it, and this matches what we just saw in the differences grid in the other instance of Visual Studio. Hook up the validation message event handler so we can run the validate selection method and see the messages in the immediate window. And those are the same messages that we normally see in the BISM Normalizer warning list. Update. Refresh the comparison and it now matches. Disconnect to release the connection to the analysis services server, and comparison implements are disposable, so unmanaged resources will get released anyway. And we're done. The command line interface that ships in the V6 for BISM Normalizer basically just runs this code. So as you can see, it's very simple from the client side. And the object model is fully documented, as you can see here. And so on. We're now going to talk about the build process. There are a couple of console application executables included in the V6 for deployment. We have the command line interface and icon setup that sets up the icon in Solution Explorer and associates BSMN files with Visual Studio. The test project applies comparisons using the command line interface and then checks that the number of tabular objects in the target databases match what we would expect. So it tests the vast majority of the code paths in the object model and the newly built command line interface. This is all driven from this targets file. Before the build, we just take the version from the V6 manifest and apply it to all of the assembly info files so that all the assemblies in the V6 have the same version that matches the extension version. The extension DLL is delay signed, so we can perform obfuscation, which means that we need to disable strong name verification at this point, just before generating the package def file, or the build will fail. There are some Visual Studio build processes that require a compiled assembly. And this is also a good point to build the associated projects and retrieve their executables for inclusion in the V6 file. And lastly, after the build, at this point the package def file has been created, the V6 file has been created, we then run our tests and extract the contents of the V6 and perform obfuscation. We could have actually performed obfuscation in the previous target before the package def file was generated, but as I said, there are some Visual Studio build processes that require a compiled assembly. They actually modify the contents of the assembly, pack some resources into it. So the consensus is to just allow Visual Studio to do its thing. Once it's done, we extract the contents of the V6, apply obfuscation, re-enable strong name verification, sign the assembly, and repack the V6. This is the command I run when I'm going to do a release. It's taken the version from the V6 manifest and applied it to the assembly info files. Disable strong name verification, build the associated assemblies. It's now running the tests. Perform obfuscation. Re-enable strong name verification, sign the assembly, pack the V6, and it's done. At this point I would just copy the V6 file up to the Visual Studio gallery, and that's all I have to do. It's a very repeatable process with minimal manual intervention. Thank you for watching.